All right, we are starting a new unit here, and you'll it basically this is unit 5 for us right now, but we've skipped a unit which would have been unit 4. We'll come back to that later, but that's not going to really matter to you. This will be our fourth unit of the year, but a lot of this will be referred to as unit 5 in the notes, and so don't worry about that. There's just some things that we can come back to later, and we want to kind of get going on some other things I think are a bit more important. So if we take a look here, this is just the front of the notes, which is the objectives, and I do like to go back to these because this is kind of what IB is telling us we need to do. And there's some review here, which is nice, but there's also some specific items that were not covered last year, and then some new items. And so this is the bonding unit. And so we learned bonding last year, and there's multiple types of bonding. And so the first type right here is the ionic bonding. And the ionic bonding is going to go through just sort of like a lot of what you guys would think of as the normal chemistry, just sort of a plus positive ion and a negative ion, so a plus and a minus going together and making a compound. So this is your crisscrossing method. This is your Roman numerals. This is all those things that you learned last year. And so that's nothing that's that big of a deal, nor did we spend a lot of time on it. Now, I like to point this out right here. In applications in skills right here, it says deduction of the formula and name of an ionic compound from its component ions, including polyatomic ions. So those are the things that are listed on the back of your periodic table. So like sulfate, carbonate, nitrate, things like that, hydroxide. And if you look right here under guidance, it says students should be familiar with the names of these polyatomic ions. These are ones that you need to memorize. Okay, so it's not really an option because these are ones that they say, hey, these are going to come up on the IB exam, and you're not going to have them in a chart. And so we're going to need to memorize some polyatomic ions at some point, not specifically for my class, but the ones that you need to know are right here. And so just make sure that you kind of refer to this at some point. So these are, phosphate, sulfate, carbonate, ammonium, hydroxide, etc. Like these are ones that we use all the time, and so they shouldn't be particularly difficult for you to know because you use them a lot. But they are something that we need to spend some time learning, and so I was kind of point that out at this time in the course, at this place in the course, that although I give you polyatomic ions on your periodic table, you do not get those on the IB exam, so you're going to need to know them. Okay, covalent bonding is next, and so you would remember this last year in terms of bonding and then drawing structures. So something like this would maybe be familiar, where you're taking carbon dioxide, and then we did this kind of thing with it, and we put some dots around it, and we did some counting, and we did some double bonds, and at the end of the day, you end up with stuff that looked kind of like this. And so we're going to be doing that again. And here's the thing. We talked to you last year about double, single, triple bonds, all that kind of thing, but we didn't even give you all of the shapes. And so you got kind of an abbreviated education on that. And so we will go through more of the shapes than you did last year. And so if you look here, covalent structures, which is 4-3, that's exactly what we did last year. It's just that we're going to be doing all the same things, but we're going to be adding in some extra shapes. So you learn tetrahedral and bent and things like that. We're going to add in some extra ones, some ones that we just didn't get to last year because there wasn't really necessary. So we're going to go ahead and get to those this year. So that'll be new. And then here, I don't know if we got to this last year or not. It just sort of depends on your teacher and what you were doing. But intermolecular forces are a set of three forces that are what holds nonmetals together. And we'll talk about that. And that's kind of weird because it's like, well, why do nonmetals even stay together? Because they have no magnetic attraction. They should technically just break apart. And we'll talk about these forces. And these are only for really, really weak compounds, things that are not solids at room temperature, things like that. But I think a lot of you probably did not talk about London dispersion forces, dipole forces, and hydrogen bonds last year. So that's something that we will go back over. And then metallic bonding. I know we didn't talk about this last year. It's just another type of bonding. So if you kind of think about the bonding unit, it's going to be covering covalent, ionic, and metallic bonding, and then look at each of them a little bit more in depth. And this last one just says further aspects of bonding. These are just some extra things that we have to learn for IB. And so there's some new things here. So we're going to learn about different types of structures, resonance structures, and formal charge, and just some other little things that you guys have not had any of this before. So this will all be new. So kind of a mix of old and new. And then hybridization, you haven't had that either. So we'll talk about all those in this unit. So let's start here in your notes. And so we're going to start here with Lewis theory. And so I don't know if you remember any of the names or anything, but last year we talked about a thing called a Lewis dot structure. And then we talked about various different types of ways to look at that. And so if you look down here at these pictures, these are different structures that are using dots. Now, it's not a Lewis dot structure specifically, but they are using the dots. And so that's kind of the concept that the dots are the electrons, and we can diagram them and look at some things. So valence, very important. We use this term a lot. And so valence means outside, outermost, things on the outside. So let's think about a chemical. A chemical is going to have possibly a large amount of electrons. So something like potassium has 19 or barium has 56. Well, not all of those electrons are important in bonding. The only ones that are important in bonding are the valence electrons, and those are the ones that are going to be on the outside. So if you look at the diagrams here with sodium and chlorine, the only electrons that matter are this one electron on the outside of sodium and then these 7 electrons on the outside of chlorine. The only ones that matter are the ones on the outside. Chlorine has 17 electrons, but only 7 of them are actually important in bonding. And so that's the valence. And so that's just going to be the electrons on the outside. They're the only ones that matter when it comes to bonding. So B says when a metal and a non-metal combine, electrons are, and then we have our first blank. So when you could take a metal and a non-metal and you put them together, those electrons are going to be transferred. They physically move. And so that's sort of a fundamental part of bonding, is that we have the two different types of bonding based upon whether the electrons are transferred or whether the electrons are shared. And so transferred means they actually move, right? Like they pick up and they go somewhere else. So it says a metal and a non-metal combining. You might want to put a little plus sign above the metal because that's what metals are, cations, and a little minus sign above the non-metals. When they do a combination or a bond, then these ions are formed, the plus and the minus. And what happens is you get what we call an ionic bond. Now, an ionic bond is actually a pretty strong bond, and the ionic bond is based upon the fact, I mean, look at the word ionic, is that you're making ions. So when you look at this picture right here, what we're looking at is that concept of the ionic bond. And so this electron here is in sodium. And what sodium does is sodium gives away an electron. It physically transfers it. So the electron shows up over here and it gives it to chlorine. It's like, hey, I don't want this electron. You take it. Well, why does sodium not want the electron? Well, if we look at a periodic table, we can figure that out. So let's go ahead and take a look at a periodic table. And let's take a look at where sodium's at. And let's think to ourselves, okay, sodium is number 11. So here's sodium right here, number 11. The goal of every single element is to be a noble gas. And so what's the easiest path to become a noble gas? Well, sodium, to be a noble gas, can either become neon at 10 or argon at 18. So the easiest path is not to gain 7 electrons and go to 18. It's to lose 1 and go to 10. So that's what it does. Sodium's like, I don't want this electron. I'm going to give it away. I'm going to become a +1, and now I'm going to be stable. And look at chlorine, number 17. Well, that's very convenient. If it gets 1, it becomes 18, and now it is very stable. And so what happens is that all these things work very nice and neat. And so what goes on is sodium's like, I need to get rid of this electron. If I can get rid of this electron, I am going to be more stable. Chlorine is like, I really need an electron. If I get it, I can be more stable. And so there we go. It all works out nice and neat. Sodium's like, here, have an electron. Chlorine takes it. So the sodium is now like neon, and the chlorine is now like argon. They're both very stable. And so giving the electron away works because the chlorine needs to be -1 and the sodium needs to be +1. So that's kind of the gist of the idea of the ionic bond is that movement. Now, there are other types of bonds, obviously, covalent bonds, metallic bonds, but that's the ionic bond. So, okay, I'm going to stop this here, and then I'm going to pick back up with a little snippet of a video that I'd like you to watch, and then we'll kind of figure